Welcome to qnawire.
All right, so here we have the equation of motion for a point on a spring. And what we want to do is find the velocity equation, and the velocity is the derivative of position. And so what we're going to do is use the product rule. So we have the first and the second. And so for the product rule, we have the first times the derivative of the second. And when we take the derivative of the second, we're using the chain rule. So the derivative of sine is cosine. So we have cosine of 2 pi t, and then the derivative of 2 pi t, the inside, is 2 pi. Then we have plus the second times the derivative of the first. And when we take the derivative of the first, we use the chain rule as well. We leave the 2, the constant, and then we have e to the negative 1.5t, that's the derivative of the outside function, times negative 1.5, that's the derivative of the inside function. And then we can simplify this. So we notice in our unsimplified form that we have a 2 and a 2 pi, so we can multiply those and that gives us 4 pi. And then we notice in the second term we have a negative 1.5 times a 2, and we multiply those and that gives us minus 3. So what we want to do now is take both the position equation and the velocity equation and graph them on a calculator. So we grab a calculator, we go to y equals, we type in the position function that we were given, and we type in the velocity function as well. And we want to look at them for times between 0 and 2. So we can go to Window, and we can change our x-min to 0 and our x-max to 2. And then we can fiddle around with different y values until we find what we like. And I decided to go from negative 7 to 6 on my y-axis. So here we have our graphs. The blue one is the original function. That's the position or equation of motion. And then the red one is the velocity. And we can see that when the position equation is increasing, the velocity is positive, and when the position equation is decreasing, the velocity is negative, and we see that happening at different points along the way. We see that when the position equation is more steep, the velocity is farther from 0, and when it's more shallow, the velocity is closer to 0.